Hello, we are the ST Genetics team and our project is the GenomX. Our contacts for this project have been Andrew Coleman and Sam Hogue. The GenomX is a machine that fills cryopreservation straws with bull semen that can later be used in the artificial insemination process. The importance of the GenomX is the zero loss function. This function is used to increase the yield of each straw by 5%. The zero loss function causes a plug at the bottom of the straws so that the straw will not absorb any of the semen during the filling stage. Essentially, the GenomX takes straws from the hopper, where the straws are initially stored, and rotates them to the pre-fill stage. In the pre-fill stage, a filler fluid is inserted into the straw, causing this cotton silica plug to harden and promoting the zero loss function. The spindle then rotates the straw to the filling stage, where a vacuum pulls the product through. The next aspect is the sealing stage. Essentially, the straw is pinched between a sonotrode and an anvil. The sonotrode carries ultrasonic vibrations to the anvil, forming the straw sealed. Afterwards, the straw filling and sealing process is then complete. Upon receiving the GenomX, it was apparent that the machine had severe reliability issues. During initial operation, the GenomX would behave in an inconsistent and unpredictable manner. While attempting to ultrasonically seal the straws, the machine would exhibit an array of behaviors. The machine would not apply enough pressure through the straw that was needed to form a strong seal. In addition to forming a straw seal, it is imperative that the weld is aesthetically pleasing and does not exhibit a lobster tail, which is caused when too much pressure is applied to the straw and can ultimately cause the straw to fail during the cryopreservation process. The overall goal of this project was to modify and improve the GenomX so that it will consistently fill and seal the straws so that it can be used in the artificial insemination process. After meeting with our sponsors at ST Genetics, the team defined the needs for our design. The initial needs have changed over the past year. Our final need analysis is as follows. First, the machine needs to produce strong and reliable welds. This will be proven by using the push test on the straws. During the push test, a paper clip is pushed into the bottom of the straws to apply pressure on the straw weld. If the straw weld does not burst, the straws pass the test. The sponsor also desired a reliability of 99% for these straw welds, and the ideal weld size is about 0.25 millimeters to avoid the undesired lobster tail effect. The GenomX also needs to run at a rate of 50 straws per minute for batch sizes greater than or equal to 2,000 straws. The machine should also run for 2 straws per cycle so that the overall productivity of the machine can increase. The final need is having the GenomX operate in a cold room of 40 degrees Fahrenheit. Our new design entails a uniform 6061 aluminum material with the same dimensions as the original anvil. The aluminum was chosen because of its better heat dissipation and dimensional stability properties when compared to the original polymer. The original design was a peak plastic, and we believe this may have been the root of the inconsistent and unreliable straw welds. Once the design was decided on, the last step was the testing aspect. The team created a test plan using Minitab to prove the functionality of the new design and meet the desired needs. The test plan was created for 99% weld reliability with a confidence level of 95%. The test plan called for a batch size of 2,000 straws and no more than 3 straws per cycle could fail the push test. The aluminum design was tested many times and the design passed the test plan and visual inspection each time, proving for this design to be better than the original design. After we completed our testing, the team concluded that we had satisfied the needs defined by our sponsors, ST Genetics.